Welcome everybody, and thanks for joining this session. And my name is Daniel. I'm working for RedHat. Today I'm going to talk a little bit about serverless function, accelerate DevOps adoption. So I'm not going to spend whole time with some boring slideware. So I'm going to be a little bit more focused on live demo thing. So yeah, please keep in mind that. So we're going to do a little bit fun stuff. So who am I first? Name is Daniel, and I work for RedHat, specialized cloud-native runtime, such as Spring and Quarkx. I'm going to talk a little bit about what Quarkx is today, and Node.js and Service Mesh and Serverless with some practice, some stuff like Kubernetes. So out of RedHat, I am the CNCF ambassador. So if you already some chance to attend the KubeCon, so we actually did it last week in Los Angeles. It's the first in-person KubeCon since the pandemic. It was great. I saw more than 3,000 people were there, and I really tried to share their thought about cloud native thing and Kubernetes thing, some stuff. So here's my information. You can contact me by Twitter and my YouTube channel and my Git repository, whatever you prefer. All right, so back in 2016, Amazon Lambda was unleashed upon the world to provide the first serverless functions at a time. With some limited resources, you can only deploy some of the language platform like Java and some of the stuff. And then you can only run the functions with a simple function at a time, and the limited resources, which means if you wanted to run your microservices maybe all the time, like a 24/7, you had to cost a lot of money for pay for that. So with that limited resources, but that's not one specific event. Because after a few years, a lot of vendors actually jump into the market. IBM Cloud and Amazon and Microsoft and Google, Serverless.com, and also Kubernetes Knative also provide serverless feature and capability. This is a really strict proof why people are really interested in serverless function. Because a lot of enterprise companies try to find out how they can reduce the maintenance costs for the last few years. And then they figure it out. So most enterprise applications don't need to run all the time, which means only 50% or less than 30% your compute resources were utilized for the last 6 months or per year. So if you could run your application, like a business application, on your demand, specific seasonality or specific time, it definitely reduces your cost and time and effort, and also people to maintain that application. That's the reason why a lot of the enterprise company really want to go forward to serverless function architecture. So how to get started serverless function? So if you're familiar with the CNCF projects, there are landscape you can get started with that. For example, here is the serverless landscape and functions, and you can see tools, and you've got security, and you've got frameworks, and you've got hosted platform like a SaaS services. Also, you can have your own manageable platform like a Kubernetes or some of the stuff. You can install this whole bunch of stuff on your infrastructure, like a bare metal or a virtual machine, whatever you prefer. So these are more than maybe 30 or 40, even 100 tools, third-party library you have to select. So it would be fun for individual developer or individual DevOps engineer, but what about the decision maker or C-level or some team leader of your developer team or DevOps team? It's too many choices for them. So we need something different to make it easy and simple and efficient, as well as a little bit familiar thing. Whenever you have a new technology stack just came out, and then the first challenge for you you need to run that new stuff maybe next 3 months or 2 weeks. Doesn't matter how long, but it's totally new learning steep curve, which means a new challenge for you because you have to still work your daily job every single day. But in the meantime, you need to run new learning paths to catch up new technologies. So today, I'm going to use Kubernetes, but a little bit more enterprise grade, like a RedHat OpenShift built on Kubernetes to deploy this application as a serverless function on top of that. And also, I'm going to use Java framework. It's a Quarkx, actually invented by RedHat 2.5 years ago. It's a 100% open source project, and then a lot of individual contributor, but also a lot of enterprise company participate in this project to make it better. So I'm going to stop our slide over here. And here's my local environment. So this is an empty directory. Okay, I'm going to try to remove this one. This is my last test one. Okay, so here's my empty directory. So the first thing is I'm going to create a new Java project to deploy serverless functions. And then you can get started from scratch, or you can clone the existing Git repository to develop the serverless function. But I'm going to start from scratch. And then there are actually multiple ways to create a new Quarkx function from Quarkx initializer as an example. When you go to Quarkx.io, oh, so internet is gone. Let me try to reconnect. ATO 2021 exclamation. Okay, so here's the Quarkx.io. Maybe I'm going to zoom in. This is the official source page. You can how to get started Quarkx, and when you click on the start coding, and you can find how to get started Quarkx application generation. You can add any Quarkx capability for enterprise application. As an example, RESTful API or data transaction, or like searching data, and then you can find how to connect to PostgreSQL or MariaDB or H2 in-memory database, Microsoft SQL database, and then Oracle database. You can actually edit in that all capability. And also, there are a bunch of stuff here and funky. I'm going to showcase a little bit later. But once you create a serverless function, you don't need to change any code to deploy multiple platforms. As a part of the multi-cloud and hybrid cloud strategy, you have to consider to create your application more flexible in a productive way, because sometimes your manager asks you, hey, I need to deploy this same business application to Amazon Lambda for serverless handling for external client. But I need to deploy this same business application to on-prem serverless platform on Kubernetes. I don't need to change any code, business logic. So how to do that? For traditional way, you change the application code and repackage and rebuild, and it's a boring job, but it's necessary. Sometimes the people made a mistake, which might ruin your entire system. So Quarkx funky capability allows the developer to packaging one application and deploy multiple serverless platforms from Amazon Lambda, Google Function, Azure Function, and on-prem Kubernetes and cloud event, etc. So this is just maybe a traditional way how to get started to create a Java application from code starter, like a Spring initializer. But it's a little bit boring and maybe not familiar with me because I'm not a developer at this moment, even though I got experience more than 10 years, maybe 10 years ago. So today I'm going to a little bit use different way here. So there are command line, like a KN is from Knative. Knative command line CLI, and then we already entitle the function capability into KN command line. I just say KN func, and then you can actually find the help, and then you can, there are multiple command line, like a build, create, and delete, deploy, etc. So I'm going to use just 2 command lines today, KN func and create. And let's say the function name, like a Quarkx, something like a FUNC, and I'm going to use runtime -l Quarkx, and I think this is it. Once I return this command 1, command line, and automatically generate a new Quarkx project. It's based on Java project. When you go to that change directory, and then see that, I can see, maybe I can make it bigger here. All right. So it's a traditional Java Maven project, but one different thing is you can see the FUNC YAML file here. This is all we needed to make this application, normal application to serverless function. So when you check this out, like a FUNC YAML file, and there are some manifesto here for Kubernetes cluster, but this is not only Kubernetes, it's also a different cluster. So the runtime Quarkx, you can actually pick different runtime, Java framework like a Spring and Quarkx, and also Node.js and TypeScript and Python and PHP and a lot of stuff I'm going to showcase a little bit later. And then here is the builder image, how to building this application as a container, like a Docker container, and push it into container registry. So let's try to run the Quarkx application using Quarkx dev. It's one of the beauty of the Quarkx Java framework. So normally, as developer, so this is the inner loop process when you develop application with the Java framework. When you change the code or add a new business logic, you need to check if that function is working properly using like a unit test, or just try to endpoint like a RESTful API, or go to web browser from front application, and it's done. And then what is the next move? You have to change the code once again, like a bug fix or editing new feature, and then recompile, rebuild, and restart your runtime. Maybe it takes maybe 5 minutes, it takes maybe 30 seconds, doesn't matter. But you have to do that as an inner loop process every single day, every single time. But Quarkx just take that off, that capability from developers. So developer doesn't need to take care of that because Quarkx will handle that thing. As you see, Quarkx is just running. And then here is, you can find the live coding. Here we go, live coding. Maybe I'm going to zoom in. Live coding activity. What does that mean? And then I'm going to stop here. So maybe this, and OK. So let's try to open this project. And this generate project a little bit old version Quarkx. So let's try to use latest one. It actually released a community project last week. So here's 1.13, and I'm going to change that, the latest one to 3.0, and this one to 3.0, and change the font file. That's it. And the one thing you can see here, I'm going to make it bigger. And here the Quarkx funky KNAV event, which dependency allows developer to build this application as a serverless function. In the end, we're going to deploy this Kubernetes cluster. So let's try to Quarkx runtime once again with the Quarkx dev. And in this case, we're going to use the latest one because the latest Quarkx version actually improve tons of developers' productivity. As an example, once you run Quarkx application, you can see here, test it, pause it, and then when you press R, it resumes testing, which we call continuous testing. A lot of enterprise companies really want to use test-driven development, aka TDD, but developer perspective, they try to skip that because we spend a little bit more time application business development rather than test-driven development because your functionality is already working. Why we have to spend more time to create test scenario? Because we have our own dedicated QA team, we only dedicated CI/CD team. They will take that off and they will handle that problem. But problem is, in reality, if you find that problem, your function is not working, it's already staging environment or even production environment. it like a technical debt. So you go back to first beginning and then try to figure out where is my problem, because the developer local environment is working. That's why TDD is a really important, all developers as well as operation team. But it's really not easy to integrate your testing capability on your framework. So Quarkx actually provides that thing. So when you press D on your hub, so web browser is really opening automatically. And then as you see, this is a Quarkx Dev UI. It's integrate built-in graphical UI for developer, which showcase what kind of capability you already have, like a Maven dependency. And here's a lot of stuff. And then when you open a small terminal window, here we see your Quarkx logo here. And then here's all tested passed, and you click on test result, and you can find your unit test result with a green color. If you got error, it will be changed to red color automatically. Whenever you change the code, you continue testing automatically trigger like a CI/CD when you push your code in the Git repository. So you could stop it, or you could resume it whenever you need. But the important thing is developer doesn't need to add any configuration, any feature set to make it happen. So I'm going to go to Dev UI, and then we have when you go back to our application code, it's automatically generated when you create the KM FUNC create command line, and then go to test directory. We have two testing scenario. One is test function, just hello world stuff, and the other one is the same, the hello world, but using JSON format. One is just a text-based, the other one is a little bit more cloud event-JSON format. And then go to Java project. We had a simple Java method here. It's actually RESTful API exposure. And then we have one func annotation. This annotation makes this method as a serverless function. Behind the scene, Quarkx AutoWire this application as a serverless, as a Knative serving on Kubernetes, and you could deploy the Amazon Lambda as a serverless, something like that. And then just the input output is JSON format, something like a messaging, and like put in your name or some of this is like another hello world example. So let's try to access the endpoint. I'm going to open new terminal window here, and then just try to echo. Something like my name, Daniel, and I'm going to use HTTP 8080, the default port, my local host, and then here's a message name Daniel, and then let's try to one more time. My prepare name Dan, and I'm going to see the Dan. So I'm working, my application totally working. I just create and generate this application project from scratch. Let's try to change the application to a little more business function, like another serverless function here. So to do that, the first thing is let's try to add the configuration, because I need to add new properties from my property file. Example like a name, something like what is say username. Let's say username and string bell. Username here, and then here is pros, and then username, save a file, and then here's the application profile here. Let's try to username. So what I say like a James here. I just save a file, and then I just save a file, and back to the here, and you got an error here. Terminal window. So because the test case expected hello, but your actual test result is hello James, because I put in the James here. And one interesting is when you go back to terminal window, you got the same error here, and then here's the configuration editor. So sometimes the developer forgot, oh, where is actual key and value I define for dev environment or a staging environment or a production environment. So maybe they need to find a property file or YAML file in a multiple directory, but Quarkx is only one single YAML file or property file, and you can put in all kind of stuff with some prefix. And you can find this dev UI, something like a username, James. So I'm going to change that like another name, Justin, and I just save a file. And then back to here. And then you can find here, hello and Justin. It's automatically applied for your runtime. And then go back to another terminal window. And then you can actually, like a Dan2, let's try to eat this one. And then here is go, we change the Dan2 and a Justin. So in the meantime, actually, I never ever tried to recompile, rebuild, and redeploy and restart this application runtime. Only thing I had to do is change my application and then just to call the access endpoint and also to see what is broken on my continuous testing capability. So just to fix the problem, just go to test window, and then let's say something like a Dan2, I just a save file, and you can see back to here, oh, like a Justin. Let's try to change that. And then back to here, and then terminal window, and here test scenario. Oh, we got a error. So allow Justin. Oh yeah, back to here. We gotta change it here. Actually, change it here and just save a file, and then rerun the application. And we got a success just one because I changed one. And the other one is actually there's no parameter as a default. And so we got all success. Success here. And when you go to the runtime terminal, as you see, all tests is passing. So I just fixed my application and then changed the test code. But according to TDD strategy, you need to change the test case first and then make sure your continuous testing is working. And then after that, you go to your application and change the code. So this is a TDD, but it's really easy because you don't need to worry about how to integrate continuous testing capability, not just for traditional application, but also serverless function. So you can have the same capability, continuous testing, and Visual for API. And then when you change it Justin, and then go back to our ID tool, and then it's already changed Justin. When you actually go to editor, and then you can change it once again, username, like my name is Daniel, and I just click on save, and then back to here, this application automatically changed that. So it's anyway you can prepare, you can change it here, change it there, but automatically framework auto-wire that thing. You don't need to recompile, restart. You just keep focusing on your application development for developer. It also guarantees your quality of your software as well. So let's try to add one more function here because some people a little bit doubt it because you just change your return code like a text from hello to world. And then what if we add a new method or what if we add a new class? It's totally different thing. Is it still working that stuff? Sure, I'm going to showcase that. So the modern Java application uses dependency injection, like a DI or CDI, context dependency injection. So we can actually do that in Quarkx because the default feature on the Quarkx. To do that, let's try to create a new function service Java file. Here we go, and then I'm going to add this application as application scope in, and let's try to add a new public method, like a return string and name, and what I would say, like a name, and return, like a welcome to ATO 2021, and let's say name. Yeah, I just save a file. That's it. And go to function. And first thing, I'm going to inject this new CDI bin, like a function service. And function service here. And let's try to new serverless function. And then the public method, just a return string, and let's say the method name. The method name is a default function name. You can actually specify new function name, something like here, something like this one. This is your function name. But if you do not specify the function name, the default is a method name, and then we got a string name, and then return, and greeting, not greeting, what do you say, function, service, and greeting, and name. That's it. I just save file. And then go to application property. So I just export the name, the function name function, because the function is the here method name. So I'm going to export a new function here, back to the here. I just change that, and I just save all my file, Java classes, and application. I'm going to skip the test using case because I don't even have time to fix the whole problem, but you already saw how it works. And then back to here, we got an error because the test scenario only focused on the previous function, but I just changed the function name. But let's try to more focus on the functionality. So in this code, something like, what is say, like Veronica, and STP 8080. And now we got to return, welcome to ATO 2021 of Veronica. So we got a new function, just expose. It's pretty cool. I don't even change any stuff. It's a new function. So I just add a new class and method and put in some CDI. And then it's all working without any recompile. So maybe you think, oh, this is maybe you spend 1 minute. But if you still rebuild, repackaging stuff, maybe you took 2 minutes. It's a 1 minute difference. But what if you have maybe 100 developers, maybe 50 developers? So the RedHat, a lot of customers, they already adopted Quarkx in their production environment and they're developing. And then they say, oh, we reduce 30% of time to develop with the same result and outcome. So this is maybe huge changes. So here's the local environment stuff. So I'm going to stop the local thing right now. And now it's time to deploy to Kubernetes serverless function. To do that, I'm going to make sure my Kubernetes namespace here. So my Kubernetes namespace is a Quarkx serverless and this cluster. So here's my cluster. As you see, the Quarkx serverless project name, which is equivalent to Kubernetes namespace, and there is no resource found here. So let's try to deploy this application to Kubernetes cluster. And back to here, so I'm going to do to FUNC once again. And in this time, we're going to deploy. First time, we're going to create project. And then we just run locally and just make sure everything is working and print some logic. Next step, in the last command line, just deploy application. I'm going to use my local, my registry, quay.io, my credential, username. You can actually use a Docker Hub or Google Git repository because we're going to packaging this application and push it into external container registry and put it down from your Kubernetes cluster and then deploy serverless. This is all happening behind the scene. I'm going to showcase the log just a bit later. And then I'm going to specify namespace, Quarkx serverless. And then I just create the purpose here. Let's try to do that. So behind the scene, we're going to use Bigpack, so one of the CNCF project, which allows you to packaging your application like a Maven build or Gradle stuff, and then after that, containerize your application as a Docker image, and push it into container registry, just so I could specify quay.io, and then try to access the Kubernetes cluster. So we're deploying cluster this function, and Knative service is becoming ready. And just we got a new endpoint here. And then go back to our web browser, and then you can see here, our new Quarkx project is showing. a little bit. This is my cluster on Amazon Cloud. So sometimes it takes a little bit longer to render the nice beauty images. So maybe I'm going to reload. OK, so we got to have the new icon, and then your application is running. And when you click build all, and then maybe I'm going to a little bit zoom in here. And as you see, here's the Quarkx version. And here we go. So it's running on JVM. And then it takes 0.8 seconds to start up. Even though it's a two function, like a hello world, but it's less than 1 second. It's pretty cool, isn't it? And then I'm going to scale it down and go back to here. The serverless function will be terminating, as you see, by default in 30 seconds. This is exactly same behavior when you run and deploy application on Amazon Lambda. If you don't have any network traffic to the function, it will be scaled down to 0, like a hibernation, or scaled down to 0, or idle, whatever you call. That is a serverless behavior. And then when you call that application, like invoking RESTful API or some of the stuff, and it will go up automatically in a second. But sometimes the application takes maybe 5 seconds or 10 seconds or even 30 seconds to start. This is one of the potential problem cold start of Amazon Lambda. So problem is how to solve that. So if your application really fast startup, maybe it solved that cold start problem. So it's already terminated. As you see, there's no blue circle in here. Let's try to access the endpoint here. So now we're going to change it like a Veronica 2. And the endpoint, I just copy from here. I just enter. And when you go back to terminal window, and then you can see it's automatically getting started. Your pod is just run. And back to here, the welcome to ATO 2021 Veronica 2. So we just finished that. And then for developer, you just keep doing your formula thing. And then you just only 2 command line from scratch to deploy Kubernetes. So and then one good thing is actually when you open your FUNC YAML file back to here, so all empty variable automatically fit it in, like image digest and runtime Quarkx, something like that. Interesting is that Quarkx actually provide native compilation capability, which means the developer build Java application as executable file. They don't need to JVM as a runtime environment, just like a Go and Node.js. So it's pretty much faster than JVM application. So let's try to give it a try. We have still more time. And then the function name, I'm going to change that, Quarkx func native. And then here is image name. I'm going to change that to make it differentiated. And here is a builder. It's the user JVM. Let's try to change that native because of the native keyword here. And I just go to terminal window and try to one more time kn func and deploy and verbose. That's it. So in the meantime, maybe I'm going to show a little bit detail just a bit later. It takes a little bit longer because native compilation, there are more steps. For example, we're going to packaging application as a Java file and then create a container image. But in the meantime, we're going to create the executable file based on that Java file. Put in the all necessary executable and libraries, something stuff. If you have some experience to build Docker container, so Docker container image put in some of the layers, like a runtime operating system layer, and an application runtime like a Tomcat web server, and actual application like a Java or Python or Node.js. This is a layer architecture. So that's why it takes a little bit longer when you're packaging Docker container rather than just application build. It's a similar concept. We're going to make it executable. As you see, there are Graalvm. We're going to actually use that to packaging application and run this executable file. It takes a little bit longer. And then in the meantime, let's try to do a little bit fun stuff here. I'm going to deploy here. So it will show 2 different pod container. And then to make differentiated, so I'm going to try to add one label here. App OpenShift.io / runtime at Quarkx. And then we all have the Quarkx here. So, and then the other one will be show up here with the native comparison. So just remember that we saw 0.8 seconds to start up the Quarkx application on running JVM. So we're going to compare native comparison, how fast the native comparison Quarkx application will start up. It will really more fit it in serverless function. So go back to terminal. And now we application build success. And now we're going to push this image into external container registry. And after that, your cluster try to put it image on your Kubernetes cluster. So that's why Knative servings become ready. And now we got a ready here, new endpoint. And back to the console, now we see two different paths. One is native, the other one is JVM. So this JVM mode is already scaled down. Let's try to logs. And here we go. So this is a native. The previous one is JVM. And then here's the interesting part. We just need to start up 12 milliseconds. Previously, 0.8 seconds. It's almost 70 times faster than startup time. So you have the same application capability and functionality. Which one would be better for your serverless function? One is it takes a millisecond. The other one is 1 second. So this is the really good chance to explore Quarkx for your serverless function. And then it's almost starting to terminating. And then just make sure try to endpoint. And then just change this one. And let's try to echo Daniel 222. HTTP is this endpoint. You can see the native here, and then just click on that. And then you're actually, in the meantime, your serverless function is already scaled down. It's automatically running, and now we got this one. So this is a really cool stuff to serverless function. And just keep in mind that we just use the two command line to deploy, create, deploy. And then we also have native comparison super fast and small memory footprint. If you compare to memory footprint, the first one is almost 100 or 80 megabyte on local machine, like a memory footprint. And the other one is 3 or 5 megabyte as a memory footprint. So it's tiny memory footprint and fast startup time for serverless. This is a really cool stuff for your new designing serverless architecture. Okay, so I'm going to showcase one little bit more interesting stuff. So this is all developer stuff. And what if you are a little bit more developer, DevOps engineer perspective? We need to define standards, our runtime environment for serverless, like a Java framework. And then here is the Helm chart. It's a really popular thing, the packaging manager, your application runtime for Kubernetes. And then install new Helm chart. And then there are actually Quarkx Helm chart. And then you can install Quarkx Helm chart. You can go to YAML file. And there are a bunch of stuff here, how to specify your build image like a JVM or a native stuff, and which Git repository you will report to application development, and the deployment strategy like a health check or another stuff. And then I just leave the default configuration here. Once I click on install, it's automatically install your Quarkx application as standard with the Helm chart. And then once it created, and then you can simply change this application as serverless. It's already almost here. So immediately full backup running, this application still building. So when you click on the building running icon, so now the application just downloaded and downloaded the Maven packaging, and then try to containerize it and pushing into container registry, just like we did using KEN command line. It's the same thing using ham chart. And then once you create that, and then just click on here, and then you can change this application to serverless right away in this web UI. So you're not going to see at this moment, but once you deploy it, and then we can find that. All right, let's give it a try, give it some time here. I got some few slides to wrap up today. I'm going to go through the wrap up slide where, and I just will get back to here to summarize this today's session. All right. So just summarize, Quarkx is open source project for Java framework, and then so for cloud native microservice and serverless function with event-driven application, and then with the Quarkx, it's very simple to develop serverless function, and there are more than 15 million Java developers out there to spend a lot of time to implement business application every single day. So they don't need to run something new stack for developing reactive application or event-driven application, even serverless function. And then I already use serverless for Knative, and FUNC. As you see, today we use Quarkx, but you can still have select Node.js, Spring Boot, and Go, and Python, Rust, and TypeScript for multiple language, framework, language, program, languages, some stuff. And then here's a ham chart. You can add ham chart or CI/CD pipeline integration, and some more stuff for more operation people. And then, as already quick brought up at the very beginning, so Quarkx Funky, not just only focus on Kubernetes, but also handle Amazon Lambda and Google function and Azure function to multiple serverless platform for your hybrid multi-cloud strategy. And here's my YouTube channel, Binny Daniel OTV. Feel free to subscribe that, and there are a lot of examples, including today's demos. And then there are a few material here. Binny URL, try-Quarkx is a self-paced interactive training course. You don't need to install any software. Just go to web browser, and then there are a bunch of the interactive courses you can just follow on that. And the code.quarkx.io, I already showed that, code generator. And here's your RedHat actually IDC performance report compared to existing application. As an example, Spring versus Quarkx for memory footprint and throughput and response time, a lot of stuff you might need to interested in for communicate your decision maker. And recently, I wrote the reference card in DZone for serverless functions, how to get started serverless function development, and also how to make your serverless function portable and then bind the cloud event, because there are a lot of messaging system which has types of different messaging format. I want to use a JSON format. I want to use a binary format. The problem is how to communicate among those different types of format, event-driven. So cloud event to provide standard image format for messaging processing. And then this is a really easy way to bind your serverless function with the cloud events. All right, so let's try to go back to the terminal window. Okay, and then here we go. So we have a new Quarkx function. And click on here, as you see, make a serverless here. When I click on make a serverless, and then here's all kind of stuff like a Quarkx serverless app, and just create one. And then now we have two different ones. So one is the traditional 24/7 running microservice as pod on Kubernetes. The other one is serverless. It will coming up soon. And then now we got to add two different ones. When you go to endpoint, and like a hello world and greeting, like a welcome to ATO 2021, and then I just enter, and now we got the same result here. Oh yeah, I just typo, yeah, maybe 2121. Okay, we got it. So that's all I have today. So if you have any question for that, I'm a Quarkx, serverless function, even CNCF and RedHat stuff, I will be hanging around out there in the RedHat booth, and please reach out to me and don't hesitate to ask any question. Thanks for attending today's session and enjoy the rest of the conference. Thank you.